All right, I'd like to now go on to, I'm going to skip 13 because that's really similar to 12, to be honest. I would like to go on to 14 and 15 because these are really quite abstract and I understand if people are having issues with them. Now, for 14, the main thing to understand is that if we've got the general form of the quadratic formula, y equals ax squared plus bx plus c, so, and we've got y equals, and the factorized form, x take alpha, x take beta. These represent the same parabola, they're just giving us different pieces of information about it. And what this question is asking us to do is to find A in terms of alpha and beta if these pieces of information are correct, and they actually are. So I'm going to expand this second one. I've got x times x, x times minus beta, minus alpha times x, minus alpha times minus beta. So I'm going to end up with y equals a outside of x squared, take beta x, take alpha x plus alpha beta. Which means once it's fully expanded, timesing everything by the a out the front, I get ax squared, take a beta x, take a alpha x plus a alpha beta. I know it looks super confusing. It will make sense shortly. What question 14a is asking us is it's specifically saying the y-intercept is c. So what it wants us to do is to look at the y-intercept, which is always the one without an x in it, and make them equal each other. So we know c is the same as a times alpha times beta. Yeah? Which means a equals alpha times beta, c over alpha times beta. Which makes sense because, like, mathematically it works. Sorry, just pausing for a sec. I'm not entirely sure where it wants me to go here. This is a feeling you guys must identify with a lot. So, I've done that. Now oh, no, that's it. That's the answer. That's what they wanted. Cool. I thought they wanted something different, but nope, they're happy with C left in it. Let's now have a look at question B. Now it says the coefficient, and I'll highlight this in a different color. The coefficient of x is b. So this is the b. And the stuff with just x, not x squared, and not no x's at all, is that, yeah? So we've got bx in our first equation, and we've got negative a beta x take a alpha x. X appears in everything, I'm going to get rid of it. B equals negative a beta take a alpha. I'm going to factorize the right hand side. So I've got I've got negative a out the front of beta plus alpha. I'm going to divide everything by beta plus alpha, get that to the other side. So I've got b over beta plus alpha, and that gives me negative a. I'm going to divide both sides by negative 1. I'll take the negative to the other side is another way of saying that. So negative b over beta plus alpha equals a. And now they're saying that the curve passes through, for 14c, the curve passes through 1, 2. So when x equals 1, y equals 2, yeah? So what we should be able to say, find a in terms of alpha and beta. Okay, so I'm definitely going to have to sub it into the second equation. My y equals a outside of x take alpha, x take beta. Are they intending for me to sub it in both of them? No, probably not. So I've got 2 equals A times 1 take alpha, 1 take beta. All I'm going to do is rearrange, divide both sides, so I'm going to get 2 over 1 take alpha, 1 take beta, and that's going to give me A. So if I know the x-intercepts, then I can find out what the value of A, the actual values of the x-intercept, sorry. But they haven't asked me to do that. That's where I'm leaving it. That's all they want. This is a very weird theoretical question. I'm not establishing anything of substance. Okay, let's have a look at question 15A. So let's factorize. I'm going to write myself directions. Factorize. So I've got f of x is x squared take 2x take 8. What times is to get negative 8 and adds to get negative 2. Negative 4 and positive 2. X take 4, x plus 2. So if I expanded it, x squared, take 4x plus 2x, yeah, take 2x. Negative 4 times 2, negative 8, cool. And now to get my x-intercepts, they're not actually asking me to sketch this. They're just wanting me to do a few steps. So x-intercepts, y equals 0, x take 4, x plus 2. So x equals 4 and x equals minus 2. Oh, why did I put that bracket there? That was weird. And the axis of symmetry, halfway between the x-intercepts, so x equals 4 plus negative 2 over 2, which gives me 1. Okay, I've found the equation of the axis of symmetry, it's x equals 1. For 15b, they say, and this, I understand if this notation really threw you, f1 plus h and f1 take h. 1 plus h. So we did this in exercise 3a. All that means is that they want you to sub 1 plus h into, and I'm going to move this down, if f of x is x squared take 2x take 8, they want you to sub 1 plus h into that. This is actually going to be easier in the factorised form. X take 4, x plus 2. So instead of x, what I'm going to write for x each time is this 1 plus 8 thing. So I've got 1 plus h take 4, 1 plus h plus 2, which is going to come out as h take 3, h plus 3. And that's f of 1 plus h. Same deal if I'm doing 1 minus h. F of 1 minus h is going to be 1 minus h take 4, 1 minus h plus 2. So here I'm going to have negative h take 3, sorry. Negative h plus 3. What do I notice? 1 take h is just the negative of 1 plus h. Would that make sense? I think they actually equal the same thing. So what I just did, it may have seemed very confusing. When I had my negative h take 3, then I could take the negative out the front and it just left with me with h plus 3, yeah? And when I had negative h plus 3, I took another negative out the front And on the inside, negative h divided by negative 1, positive h, positive 3 divided by negative 1, negative 3. And then it was my negative times the negative comes out as positive, which gave me the exact same answer as I had here. This shows us that it's symmetrical. That's all. Around. Well, if 1 minus something gives us the same answer as 1 plus something, then 1 must have been our axis of symmetry. That's all. All right.